Okay, perfect. It works. Now I'm gonna share my board. All right. And here's the board. I hope you can see the board, guys. Let me know, please let me know if you have any problem, technical problem. I mean, I know this is all crazy, but I hope it's gonna be over next year. Anyway, so um, so as I said, we're gonna start. So this is a new section, section 1.7. And so what we're gonna do, we're gonna combine, so combination. Um, I see there is a message. Tomorrow, yes, yeah, that's actually a very good question. Yes, so we're gonna meet tomorrow at 12 as usual. Yes, absolutely. So tomorrow is just the usual time. Yes. Mm-hmm. So, so combination and composition of functions. Composition of functions. Thank you for the quick tip. Functions. So the goal today, guys, is first to do some algebraic operations on functions. So what I mean by algebraic operations, I mean the addition, subtraction, multiplication, division, right? So today, so first thing we're gonna do algebraic operations on functions, and so what I mean by algebraic operations, I mean addition. We're gonna add function, we're gonna subtraction, we're gonna subtract functions, multiply functions as we do for numbers. So multiplication, and of course we can also divide. We can divide functions, right? Well, so let me first show you the examples how to do that. And I'm gonna, at the same time, I'm gonna introduce some notation here. Notation. So let me start with the sum of functions, or sum of functions. So the sum of functions is denoted. So let's say you have two functions, f and g. So let's say you have f of x and g of x be two functions. So we have two functions, and then the sum is denoted by f plus g. So we write f plus g, okay, between parentheses and then x. So when you see f plus g, that means f of x, of course, plus g of x. All right. So for example, so let's say you have f of x is negative 2x squared plus 5x minus 4, and let's say g of x is 3x squared minus 6x plus 2. All right. So now let's say you want to compute f plus g. So when we write f plus g of x, that means that will be f of x plus g of x, right? So well, then what we do is the following. So here's my f of x. So here, this is my f of x first. So here's my f of x. So we have like negative 2x squared plus 5x minus 4. That's my f. And then there's a plus g of x. So here's my plus. So here's plus g of x. And then we have g of x, which is 3x squared minus 6x plus 2. right? So that would be my g of x, right? So now, guys, next step. No problem, Samira. I got your name. Thank you. So now, guys, next step is you need to simplify. So don't forget. So next step is to simplify. So like here you have, so x squared. We do have, minus 2x squared, and here plus 3x squared. So that will be minus 2x squared plus 3x squared. That will be plus x squared. So here we're going to have x squared. The next x's. So we have plus 5x minus 6x. So that will be minus 1x, right? Or minus x. So we're going to have minus x. And then for the constant, we do have here minus 4 or negative 4 plus 2. So that will be minus 2 or negative 2. So here I'm going to be minus 2, right? Yes. Yeah, you combine the terms. Yeah, this like terms. Yes, absolutely. So you combine like the terms, and then so that will be your final. This will be your final answer. So my point here, guys, is that you need to simplify. You need to combine. If you have the similar terms, then you have to combine them, right? So your answer should be like, so f plus g of x is x squared minus x minus 2. Okay, so as I said, here you have to simplify. Right? So that's for the f plus g, right? So now, so that's the addition, right? So next, of course, we're gonna have subtraction. So with subtraction, guys, we need to be a little bit careful because we'll see because of the sign. So next, number 2, we're gonna have subtraction. So we write, so f minus g of x, so that will be f of x minus g of x, right? So the notation here for subtraction f of x minus g of x is f minus g of x. And as I said, you need to be careful because you're gonna need parentheses here. So example, so let me just take probably the same example. So example f of x, let's say it's again minus 2x squared plus 5x minus 4. And g of x, let's say the same g of x, which is the 3x squared minus 6x plus 2. So then when you do f minus g, so then you do f, let's say minus g of x. And as I said, that will be f of x. So that will be the notation for f of x minus g of x. All right, so first, okay, so as usual, so first we start with f. So we have like f would be minus 2x squared plus 5x minus 4. Again, that's f, right? Here's my f, right? And then we have minus. So here's minus subtraction. So here's minus. But then, guys, the function g of x comes with parentheses. So we're gonna need parentheses here for the g of x. Okay, so just be careful for the g when you do subtraction. You're gonna need parentheses. So that will be so here we're gonna have inside the parentheses we're gonna have g of x, which is 3x squared minus 6x plus 2. Yes, always. Yes, always a parenthesis because the problem, Glenn, is that because you have to distribute the sign, and when you distribute the sign, if you have like minus minus, that will be a plus. So otherwise, if you don't put the parentheses, then you're gonna get the wrong sign. Okay, so like here, you have to distribute the sign. So it's like minus 2x squared plus 5x minus 4. So then we have minus 3x squared, okay? But then you see here, because I have the parentheses, then you have minus minus, that will be a plus 6x, right? So just be careful. So this is a plus here because we distribute the sign, and minus plus 2, that will be minus 2. So then we're gonna have minus 2. So that's a different sign, right? So it's a different sign. So if you don't put the parentheses, then, instead of minus 2, you're gonna end up with plus 2, which is wrong. Okay? And of course, now that the next step would be to simplify. So here, sorry. Next step would be to simplify. So here, simplify. So like, you have the x, we start with the x squared. So we have the minus 2x squared here, minus 3x squared. So that's gonna be minus 5x squared. So first we're gonna have minus 5x squared. All right, now the x's, we do have plus 5x. So here it's plus 5x here, plus 6x here. So that'll be plus 11x. So here it's gonna be plus 11x. Now the constant, so we have minus 4. This is minus 4 here, minus 2. So that'll be minus 6. And so that would be the final answer, right? So then your f minus g of x would be minus 5x squared plus 11x minus 6. Okay. And again, if you don't put parentheses, then you're gonna end up with the wrong answer. Okay, so now let me make a similar remark about the product or multiplication. So the multiplication, so this is operation number 3, of course. Here's multiplication for product. So multiplication. So we write f dot g of x. So the dot means product, right? So this is a product. Later, guys, in the same section, we're gonna see composition of functions, and the symbol for composition of functions is like a circle. So we're gonna have like a dot and the circle. So just don't be confused. So when you have a dot, that's a multiplication, all right? So f times g of x, that's just f of x times g of x. And again, we're gonna need parentheses. So for example, let's say f of x, is 2x minus 1, and g of x is minus 3x plus 2. All right. Now, if you do f times g of x, so as I said, that's like f of x times g of x. So now for multiplication, we're gonna need parentheses for both. So we're gonna need, so that will be equal. So I'm gonna need parentheses here and parentheses here. So for f, it's 2x minus 1. And then we have the dot, so that's a multiplication. Here's my dot. And then g of x, which is minus 3x plus 2. All right. Now, so that'll be equal. And now we have to distribute, right? So just be careful with the distribution. So like, like 2x here times minus the x, 2x times 2, and then the minus 1 here times the negative 3x, and then times the 2, right? So we have to distribute. So 2x times minus 3x, so that'll be negative 2 times the negative 3, so that'll be negative 6. X times x, that would be x squared, right? And then 2x times, so plus 2, that would be 2 times 2, that would be 4. So that's plus 4x. So we are done with the 2x. Now I can move to this minus 1, right? Minus 1 times negative 3x. So negative 1 times negative 3, that would be positive 3. So that's plus 3x. And then -1 times +2, so that will be -2. Right, so then you have to simplify. Okay, so next step, so equal. So here we need to simplify. So how many x squared do we have? Well, we only have minus 6x squared, right? That's the only x squared we have. So that's negative 6x squared. Now, the x's, so how many x's? So we have plus 4x, right? And then plus 3x. Yeah, Lenin, yeah, absolutely. So that'll be plus 7x. Yeah, absolutely. So that's plus 7x. And then there's only a constant, only one constant, which is -2. So that's -2. So, and that will be, of course, your answer. So the f times g, once you're done with the simplification, so that will be final answer. So that's -6x squared plus 7x minus 2. All right. So just be careful, guys. You know, the parentheses, and then you need to simplify, as I said. So if there is no question about this, about the multiplication, then let me just introduce the notation for division, and then probably we can have an exercise. So last operation would be the division. So number 4, division. Right. So we write f over g. So when you write f over g of x, that means that's like f of x over g of x. So for example, example here. Let's just take a very simple example. So let's say f of x is x and g of x is x plus 1, right? So then f over g of x, so that's f of x by definition. So it's f of x over g of x, right? So then f of x is x, and g of x is just x plus 1. Well, here x over x plus 1, there's no cancellation, or there's no simplification here, right? So it's just, that will be just the final answer because there's nothing to simplify here. So it's just the final answer. So f over g of x is equal to x over x plus 1, all right? Okay, so is there any question about the notation or the operations here? Okay. Well, that's perfect. So then, yeah, before the graphs, so let me just probably give you an exercise, similar problem. So let me probably move to the next page. So here's an exercise. So let's say.
Professor, could you go back for a second?
Yeah, sure. No problem. The bottom, right? I
Yeah, the
guess.
bottom. Yeah.
Mm-hmm. So after the exercise, guys, we're gonna see we're gonna do operations, but using graphs. Okay, so it's
All right, thank you.
sure, okay. So okay, yeah, here's an exercise. So f of x. Let's let f of x be equal to, let's say, minus 4x plus 3, and g of x is, let's say, 2x minus 1, all right? So what you need to do, guys, so please compute f plus g of x, f minus g of x, all right? Then f times g of x, and then f over g of x. Okay. So guys, please don't forget to simplify your answer. All right. So it's really important. I'm gonna give you a couple of minutes to do this exercise. All right. So again, guys, please, yeah, Kwame, you're saying first, uh, yes, correct. Your answer is correct, Kwame, yes. So yeah, I was saying, guys, please make sure that you got your grade because because some people upload the homework on Blackboard. Some people send me the homework to my Gmail, to my BCC. So sometimes because I have so many emails, so then sometimes I can miss or I forget to check your email, so or your homework. So please make sure that you got your grade, especially if you send your homework by email.
Professor, one question about the homework.
Mhm.
I sent it right to your Gmail, but I got a confirmation of the homework number 2, so it was the second time.
The number two, yeah, it's fine. Yeah.
No,
Mhm.
no, but I
Yeah.
mean,
So,
I
so
sent it to you number 3, but I
yeah,
didn't.
number three. Yeah, number three because I didn't start grading number three. So I would, probably next Monday you will receive an email from me with your grade, right? Um, uh,
Professor,
Okay.
Professor,
I posted mine on Blackboard, but I need you to take a look at it because I don't know if you're able to see it because I had zoomed out and took a screenshot from my iPad.
okay.
So I don't
did you check if
know and look at my graph.
did you check if your grade is there for homework number two? I'm talking about homework
No,
number.
I'm talking about homework number 3.
Oh, homework number three. Okay. Oh,
Yeah, so I used an app and I don't know if you're able to because you have to zoom in to see my graph.
okay. Okay. I will check it. I will check it.
okay,
Okay.
Professor. Okay, for me, I submitted
Yeah, I
the
know.
homework number 2.
Yeah, yeah, I know. I got your email this morning. Yes.
Okay, fine, thank you.
Oh, I see. Oh, okay, okay. Oh, I see. I see. Okay, okay, Leah. Yeah, I will check it. Yeah.
Okay.
Mhm. Um. Yes, Kwame, that's correct. That's minus 6x plus 4 for number, yeah, for second one. Yes. Okay, guys, I guess probably you're done with this exercise. Okay. Then, okay, so for number one, so you have your f of x, which is minus 4x plus 3. So here's my f of x minus 4x plus 3. And then we do have a plus, so here's my plus. And then we have g of x, so that's 2x minus 1. For the addition, guys, you don't really need the parentheses, all right? So then final answer would be, of course, here you need to simplify, minus 4x here, plus 2x here. So that would be minus 2x. And then there is a plus 3, and there's a minus 1, so that would be plus 2. All right, so minus 2x plus 2. So that's the final answer. Um, for number 2, so you have your f, which is minus 4x again plus 3. And then you have minus, but then as I said, for subtraction, it's a good idea to use a parentheses here. Otherwise, you're gonna end up with the wrong answer. So minus, and then between parentheses, we have g of x, which is 2x minus 1. All right. So now that will be, minus 4x plus 3, then minus 2x, and then minus, that will be a plus, so that will be plus 1. All right. And so we're going to have, now we're going to simplify. So this is minus 4x minus 2x. So that's, as you said, Kwame, that's minus 6x. So here's minus 6x, and then the plus 3 plus 1. So here we have plus 3 and plus 1, so that will be plus 4. So that's correct answer. Okay, so for number 3, yes, Amira, I think there is an x squared for sure, yes. So you need to just be careful. So for multiplication here, as I said, we're gonna need parentheses for both, for f and g. So here's my parentheses, f, and here's parentheses for g. So first, between the first parentheses, I'm gonna put f. So here's my 4x plus 3. And then this is a dot, that's multiplication. So here's my dot. And then g of x between the second parentheses, that's 2x minus 1. All right. So then just be careful, guys, with distribution when you distribute. So we're gonna have first, let's say this minus 4x times the 2x, and then plus minus 4x times the negative 1, right? So first, we're gonna have, probably I'm gonna just erase this because I don't have enough space. So as I said, so minus 4x times 2x, that's minus 8x squared. X times x, so it'll be x squared. Yes, Samira, so it's x squared minus 4x times negative 1. So minus 4 times negative 1, that would be plus 4. So that's plus 4x. All right, so we are done with minus 4x. Now I can move to the plus 3. So here's plus 3 times 2x, and then the plus 3 times the negative 1. So plus 3 times 2x, that will be plus 6. All right, so plus 6x, and plus 3 times negative 1, that will be minus 3, right? So let's see here what happens. X squared, we do have only one square, x squared, only one x squared, so it's minus 8x squared. The x's, we do have plus 4x and plus 6. So that would be plus 10. Absolutely, Samira. So you're correct. So final answer here would be plus 10x. And of course, there's minus 3. So here's minus 3. So yeah, so that will be a final answer for f times g. Now for f over g, it's just f of x over g of x. So f is in the top. So here's my minus 4x plus 3. And there's g in the bottom. So here's my 2x minus 1. So here again, there's no simplification here. So that will be a final answer. So that will be my f over g of x. All right. Is there any question, guys? No questions. So, okay. So now next, we're going to use graphs. So next, we're going to use.
So how about the last one? We doing it?
Excuse me? The last one, the f over g?
Also, that's going to be the answer. No, nothing else?
Yes. That's the final answer. That's the final answer for the last one, right? That's the f over g.
Oh, I think g isn't g like x plus 1? That's the formula, I think.
No, g is 2x minus 1.
No, I know. I'm saying like it's on the previous page. Can you go back?
Before the exercise, okay.
Yeah.
But it's different.
Down, all the way down. Yeah.
Yeah, but this is different example, right? Here in this example,
Yeah.
your g is x plus 1. Yes.
So you just leave the answer like that if you cannot like simplify it.
Yeah, we cannot really simplify. Yeah.
Oh, okay, got it.
Mm-hmm.
Thank you.
Here's the same thing. I mean, so we have 2x minus 1. I mean, we have here in the bottom 2x minus 1, and that's it because we cannot really simplify here the fraction. Yeah, so I was saying now we're gonna use graphs, right, to do these operations. So let me show you as an example here. How do we use the graphs? So using graphs, right? So let me I give you an example. What do I mean by using graphs to do operations? So first, let me graph two functions. So I'm gonna take this as 1. Remember lines here. This is -1, -2. This is 1 here, -1 here, and here's my -2. So I'm gonna graph f first. So here's my f. So this is my f of x. All right, so this is f of x. Now g of x. All right, so g of x is the green graph, right? That's my g of x. Right? So you have two different graphs, f and g. Now, what I'm going to do, I'm going to find, let's say you want to find f or f minus f plus, let's say plus g of, let's say, -2. All right. So then let's say you want to find g minus f of, say, 0. All right, and then let's say you want to find f times g of +1, and then let's say you want to find f over g of 0. All right, so let me start with the f plus g of -1. So what do I mean by this f plus g of -1? Well, it's like f plus g of x, but here my input x is -2, right? So it's like, here it's like saying f of x, but my input x, my x is -2. So that's like f of -2, and then we have a plus, right? This is a plus here, so I'm gonna have a plus. All right, and then g of x, but again, my input x is -2, so that's g of -2. All right, so now what I'm gonna do, I'm gonna try to use the graph to find these values. So first, I need to find f of -2, right? Here, I have f of -2. So here's -2, my x is -2, right? So I'm gonna go up here to find f of -2, right? That's the red graph. So f of -2 would be, it corresponds to +1. So here, this is actually equal. So f of -2 is gonna be +1. Now, what about g of -2? So here we have a plus, so here's my plus, and then g of -2. So here's, again, this is my -2, and g of -2 is gonna be the same point, right? It's this one here, right? Which corresponds to y equal to 0. So g of -2 would be 0. So this is 1 plus 0, right? And 1 plus 0 is equal to 1, right? So, and of course, 1 would be the final answer. All right, so you see, guys, so once you have this, your f -2 plus g of -2, then you're gonna use the graph to find the values, the corresponding values for the output y, right? And then you're gonna add, so we got 1 here plus 0, so there'll be 1.
Oh, so the 1 and the 0, those are the values for y, right?
Yes, yeah, that's the values of y, yes. Like f of -2, f of -2, we said it's +1 because, you go up, this is my x -2, right? You go up here, right? You get this point, this is the image, so, and it corresponds to y equal to +1, right? That's how we got +1 there. So like for the next we have g minus f of 0. So we have to respect the order here, guys. So first we have g, so we're gonna start with g of x. My x is 0, so it's gonna be g of 0. And then we have subtraction, right? So it's minus. So here's my minus. And then you have f, and of course it's not f of x, but because my input x is 0, so it's going to be f of 0. So now what I need to do is I need to find, first I need to find g of 0. So here's x equal to 0, right? This is x equal to 0. And g of 0 is going to be the same point because g is, the green graph, right? So g of 0 is just the same point, which is 0, which is the origin, right? So the corresponding y would be 0. So here is going to be 0. And then we have minus, so here's my minus, and then we have f of 0, right? We have f of 0 here. So let's find f of 0. So this is my x equal to 0. To find f of 0, I need to go to the red graph, the graph of f. So I need to go down here, and this is f of 0. And it corresponds to y equal to -2. Yes, Leah. Yes, it's -2. Thank you. So it's minus -2. All right, so now I have 0 minus -2, so that would be positive 2. All right, so the answer would be positive 2. All right. Is there any question, guys, about how I got this g minus f of 0? All right. Now, f times g, right? This is the dot, this is multiplication, so f of times g of 1, right? My x is 1, so it's like f of x, but x's input is 1, so f of 1 times, because I have multiplication, right? Now, in this example, now I have a multiplication, so times g of x, my input x is 1, so that's g of 1, all right? So now I need to find f of 1, so here's 1, right? That's my x equal to 1, right? Now, what will be f of 1? So f of 1, it's, you have this empty dot, right? Here's my f. This is supposed to be my f of 1, but it's empty dot, so it's excluded, right? Remember, guys, when you have this empty dot, it's excluded. So when you say it's excluded, it means it's undefined. All right, so f of 1 is actually undefined. This is undefined. All right. Yes, it's excluded, Glenn. Yes, absolutely. Yeah. So if it's excluded, it means it's not. So it's not. It doesn't belong to the graph, right? So then f of 1 is undefined. We don't have f of 1. And then, of course, undefined times wherever, it doesn't really matter, right? Because if it's undefined, then the whole thing is going to be undefined, right? So the f of 1 times g of 1 is going to be undefined. So the whole thing is going to be undefined. So that's the final answer. Final answer is undefined. All right. Again, it's undefined because f of 1 is undefined, and f of 1 is undefined because it's excluded. Right now, next, f over g of 0, I'm going to just move it to the bottom a little bit. So f over g of 0. Okay, so this is division. So I'm supposed to have f of x, but my x is 0. So my x is 0. So that will be like f of 0 over g of, well, my x is 0, so that will be also g of 0. Now, what's f of 0? Well, here's 0, right? This is 0 on my x-axis, and to find f of 0, I need to go to the red graph. So I'm going to go down here. So f of 0 would be -2. All right. So f of 0 is -2 divided by g of 0. And so what's g of 0? Remember, guys, now it's a mess, of course, but g of 0 is supposed to be here. All right. And I mean, g of 0 is just the origin, right? And the corresponding y is 0. So g of 0 is 0. So that's here, it's just 0. Now, -2 over 0, all right? We are not allowed to divide by 0. So this is undefined. So the answer here and defined. Because we cannot divide by 0. Right? Of course, if you had like 0 over -2, if you have 0 in the top and -2 in the bottom, 0 over -2, that will be 0. The answer would be 0, right? So if you have a 0 in the top, the answer would be 0. If you have a 0 in the bottom, that's undefined. So here in this case, it's undefined. Any question, guys? So let's have a similar exercise then. So let me give you 2 graphs. So exercise, here's exercise, and here are my graphs. So here, so I'm gonna need 1, I'm gonna need 2 here, 1, 2, -1, and let's say -2. So let's say here's, and I'm gonna need, of course, -1 here. So I'm gonna have, first point is here, all right, then here, and then here, and then here. So it goes like this. So that's my F. Now my G is the following. So here's my G. This is my G of X. It goes here, and then again down here, and then I'm gonna go up here, and then again down here. Okay, so that's my G of X. All right. So what you have to do, guys, is to find. So please find or compute. So find. So G plus F of positive, or let's say -2, right? G times F of let's say -1, right? G over F of -1, right? And then F over G of, let's say, +2. All right. So, okay, so you have a couple of minutes, guys, to find these values. So I don't know if I hope the graphs are clear. I mean, you know, this is, again, this is +1, +2. Yeah. So I'm here to answer your questions, guys, if you have any. So we'll meet tomorrow at 12, right?
What do you say, Professor? Tomorrow we're meeting at 12, right?
Yeah, the usual time, yes. I mean today. I mean tomorrow. You have the normal schedule. So any guess for number one, guys? Any guess for the g plus f of -2? What will be the answer for number Yelisa? Yes, very good, Leah. Samira, yeah, correct. It's correct. It's gonna be 0 for the first one. Yeah, absolutely. So it should be g of -2 plus f of -2. Okay, just be careful with the graph. So g of -2 would be this point here and corresponds to 1, and f of -2 would be this point here and it actually corresponds to -1. So the g of -2 would be +1 plus, and then the f of -2 would be -1. So that's 1 plus -1, and the answer, yes, so it's going to be 0. Yes, absolutely. Ilya, yes, -1. Now, what about number 2? Any guess for number 2? 0. Yes, absolutely, Samira. So for number 2, so it's a g of -1 and then times, it's a multiplication here, so product f of -1, g of -1, here's my -1. G of -1 is the same point, right, which lies on the x-axis. So the corresponding y would be 0. So that's 0 times, and f of -1, it will be, so here is my f of -1, which corresponds to +1. Yeah, absolutely, Leah. That would be positive. 0 times +1. So here's +1. So the answer, of course, 0 times any number is just 0. Okay, what about number 3? Any guess? Well, yes, actually, yes, it's gonna be 0, Samira, because so it's it's g of -1 and over f of -1, right? So just be careful, guys. I mean, you have the g in the top, so your g goes in the top, and you have f in the bottom, so f goes in here in the bottom. So, and we said g of -1 should be 0, and f of -1, it's +1, and 0 over any non-zero number is just 0. So again, if you have a 0 in the top, the answer would be 0. If you have 0 in the bottom, the answer is undefined. Okay, so now for number last one, so we have f in the top. So in the top, we're going to have f. So it's f of 2. The g is in the bottom, so that's g of 2. F of 2, so here's 2, right? F of 2 would be here at this point, which corresponds to +1. So f of 2 is +1. And g of 2, yes, absolutely, Samira, Elisa, it's undefined because g of 2 is just the same. It's here, it's on the x-axis, and the corresponding y would be 0. So g of 2 is just a 0. So 1 over 0 and 0 in the bottom, so that's undefined. So the answer is undefined. I'm sorry, I should probably move this thing here a little bit to the left. Yeah, so the answer is undefined. Right? Any question, guys? Okay, perfect. Then, so So the next thing or next question is, you know, we know how to find the domain of a function, right? The domain of a function f or domain of a function g. So now the question is, what will be the domain of f plus g? Oh, I see there's a question from Daniela. You're saying why g of 2 is 0? Well, because, okay, so let me explain to you here. We are supposed to have, um, so here's my g of x, right? That's the green function is g of x. So you see, Daniela, here, it's where x is equal to 2, right? That's my x equal to 2. So I want to find the corresponding g of 2, right? So g of 2 is, you know, you don't have to go anywhere because this is also the g of 2, right? This is here, this is g of 2, right? Because g is my green function. So here's my g of 2. Now, what's the corresponding y? So if you go to the left, to the y-axis, so you see here, I mean, the corresponding y would be this, which is 0, right? It corresponds to that, to the 0, right? So we have to go to the y-axis to see what's the corresponding y value. Is there any other question, guys? Okay. Okay, perfect. So yeah, so I was saying we're gonna try now. Yeah, so I was saying we know how to find the domain of a function f. We know how to find the domain of a function g. So the question is, what about the domain of f plus g, or domain of g over f, or whatever? Okay, so the question now is to so we're gonna try to find. So we're gonna find, so what's the domain? Find the domain of f plus g, f minus g, f times g, and f over g. Okay. You know, you know how to find domain of f, we know how to find the domain of g. So the question is, what about the domain of f plus g or f minus g, etc. Okay, so to answer this question, so before answering this question, I'm going to introduce some notation. Here's notation. So I'm going to denote by df. So d with the subscript f. So df be the domain of f of x. Okay, d subscript g, let's say that will be the domain of g. Remember, guys, what I mean. So what I mean by domain, that's the set of input, the inputs x that you can input in the function f, right? So the domain, that's the set of the inputs, right, that you can input in the function. Right, so we have the d subscript f, that's the domain of f, d subscript g, that's the domain of g. Now the intersection or the common domain, for two functions, for the functions f and g, so what I mean by common domain is the intersection domain. So this is, so the common domain means the intersection domain. So that's the intersection domain. So the common domain for the functions f and g is actually denoted by, so df or d subscript f, and then we have we reverse a capital U, so capital U reversed. So here's my capital U reversed, okay, and DG. So again, this symbol here, this reverse capital U, this one here means intersection. You know, if you have a capital U, if you have a capital U, that will be union, and when you reverse a capital U, that will be intersection. Okay, so this is intersection. So this is a symbol for intersection. So it's DF intersected with the DG, right? Now, so let me show you now with a couple of examples how to find this common domain or the intersection domain. So a couple of examples. Okay, so let's say f of x is square root of, let's say, x plus 2, all right? And g of x is square root of 1 minus x, right? And the question is, find the intersection domain or the common domain. So find the common domain. Right, so DF intersected with DG, right? So in general, guys, there are mainly 3 steps. If you want to find this common domain, so there are basically 3 steps. First step would be to, there are 3 steps. So step 1, step 2, and there's a step 3. If you want to find this common domain. So first, in the first step, you have to find domain of F. Or DF. The second step, you need to find domain of G. And then in the last step, you can find the intersection domain. You can find DF intersecting with DG, right? So for example, yeah, so here, so let's follow these steps. So here, my first function, so step 1, my function f of x, so we're going to find domain of f, right? So my function f is this one here, right? So this is my function f here. So f of x is square root of x plus 2, right? So remember, guys, if you want to find, I want to find domain of f, right? So if you want to find domain of function, you need to ask yourself 2 questions. Is there a division? And is there a square root? So is there a division here? F of x is square root of x plus 2. So there's no division, right? So no division, which is good news. All right. Now, is there a square root? Yes. So we do have a square root. There is a square root. All right. And remember, guys, the rule is we cannot have negative numbers under the square root, right? So under this square root here, we have x plus 2. So this x plus 2 cannot be negative. It has to be positive or 0. Okay, so it has to be positive or 0. So my x plus 2, so x plus 2 has to be positive or 0, or larger or equal to 0. So this is larger or greater or equal to 0, right? So that's why I have this larger or equal to 0. So because I have a square root and the expression under the square root cannot be negative, right? So now I can I can solve for x. So so there'll be, you subtract 2 both sides. So then your x is larger than negative 2. Right? So then domain of f, I mean, here's your number line, here's negative 2. So domain of f would be any number larger or equal to negative 2. So here's my negative 2, And so that will be my domain of F, right? So your answer, of course, the domain, the answer for the domain should be in interval notation. So the answer, so df, or the domain of F, is any number larger or equal to -2. So that will be -2 included, right? Because x can be equal to -2 to positive, sorry, this is positive infinity. Here's a negative infinity. So to positive infinity, right? That's the domain of F. All right. Is there any question, guys, how I got this domain? So again, the domain, there are two things to check: division and the square root. So here we have the square root. Make sure that this is the expression and the square root is positive or 0. Now, the step 2, we need to find the domain of G. Right? The step 2, that will be the domain of G. So let me write down again G. So G, we said, it's a square root of 1 minus x. So my G is square root of 1 minus x, right? So again, here, same question. Is there a division? Nope, that's a good. Is there a square root? Yes, we do have a square root. So then the expression under, the whole expression under the square root must be positive or 0. So 1 minus x must be positive or 0. So it's larger or equal to 0. All right. Okay, so now let's solve for x and subtract 1. So that's negative x, larger or equal to -1. So this is not exactly x; it's negative minus x. So we need to get rid of the negative, right? So I'm gonna divide both sides by -1, right? So because once you divide by -1, you can get rid of the negative sign, so it becomes positive, right? Now, just be careful when you divide or multiply by a negative number, then you need to change the direction of your inequality. So this is now x less or equal to +1, right? So this is because, so you have to change. So it's because, we divided by a negative number. By negative. All right, so it's actually now, it's not larger or equal, now it's less or equal. So this is, of course, this is less or equal. So my x, so my x is now, has to be less or equal to 1. So here's, here's my number line, here's 1, and my x is less or equal to 1. 1 included because x can be equal to 1, right? So the answer to the step 2 is the domain of G is negative infinity. Of course, infinity is always excluded. Kwame, you're asking the sign changes, or what do you mean for this x?
Oh, that was when you were doing the division by the.
Yeah, by -1.
Yeah.
Yeah. You have to change the yeah. If you multiply or the sign change the inequality. Yes. So so domain of sorry. So domain of G is a negative infinity. Infinity is always excluded, and then +1, which is included because x can be equal to +1. Right. So that's the step 2. I got my domain of F. I got my domain of G. So now I can move to the last step. So this is step 3. So let me just write down here for your convenience. So this is the domain of F. The domain of F, we said it's -2 positive infinity. So it's -2 positive infinity. And then domain of G is negative infinity, +1 included, right? Now I want to find the intersection or the common df intersected with dg, the common domain. Okay, so now I'm gonna find the common domain. So I'm gonna draw my number line. All right, here's my negative infinity, here's my positive infinity, right? And I need +1 and I need -2, right? Because here's -2 and here's +1. So I'm gonna need -2 on the number line, and I'm gonna need +1. Now, domain of f, it's -2, positive infinity. So it goes from -2 to positive infinity. So this is domain of f, right? Sorry, domain of f. Domain of f. Right? Now, domain of g, we said it's less than, from negative infinity to +1 is the domain of g. So here's domain of g, right? That's the green domain, right? Now the question, guys. So I want to find the common domain. So what does it mean, common domain? It means the intersection. It means so any interval which belongs at the same time to the domain of f and the domain of g. So which interval is actually colored with the same time with the red and the green? So that will be the interval between -2 and it's -2, right? It's -2 and +1. So this interval here, you see this interval between -2 and +1? So it's colored, I mean, it's red and green at the same time, right? So this is red and
So it wouldn't be the points that's in between either?
oh yeah, of course. Yeah, so there's gonna be the whole interval, the whole thing, yeah, the whole interval from -2 to +1.
Okay.
It belongs to the domain of G. It's green, and it's also red, right? It belongs to the domain of F. So the whole interval between -2 and +1. So it's red and green at the same time. So that would be the intersection or the common, common domain. So that's so the main intersection domain. So it will be -2, +1, and we need to include -2, right? Because I mean, -2 is included in the domain of f, and obviously it belongs to the domain of g. So -2 is included. +1, same thing. +1 is, you see here, this is my +1. This is my +1, and here's my -2, of course. And +1 is also included, right? And so that will be the answer. And of course, any value, I mean, any point or any point between -2 and +1 is, I mean, belongs to this intersection domain, of course. Is there any question, guys? Okay, no. Okay, perfect. So let's see. Do I have time for another example? Okay, so let's. Okay, well, let me then give you an exercise. All right. So that's the idea, right? So so when you want to find this intersection or common domain, there are 3 steps: find domain of f, find domain of g. Okay, and the last step, I think it probably is a good idea, to draw a number line, and then graph or draw your domain of f, domain of g, and you need to take the intersection, all the values which belong to at the same time to the domain of f and the domain of g. All right, so let's do an exercise where you have to find the common domain. So exercise. All right, so please find df intersected with dg, right? So first, so let me just give you a similar problem. So let's say f of x is 1 plus square root of 2 minus x, right? And g of x is square root of x plus, let's say, 4, right? And number 2, so number 2, I'm gonna use division for number 2. So let's say you have 1 over, let's say, x squared minus 1, all right? And g of x is, let's say, square root of, let's say, 2 plus x, right? So please, guys, find in both cases here, find the intersection or the common domain to F and G, right? So I'm going to give you a couple of minutes, guys, to think about this exercise. Please follow the same steps, right? First, step 1, find domain of F. Step 2, find domain of G. Step 3, you need to take the intersection, all right, between the two domains, right? The one doesn't count. What do you mean again by the one doesn't count? You mean
In f of x, 1 plus square root of 2.
yes. You're talking about the first. Yes.
Yeah, doesn't count is 8 because it's outside, right?
Yeah. Absolutely. Yeah. You're correct. Yeah, that's a good point. Yes. Mm-hmm. I thought you were talking about the previous example. Yes, you're right. Actually, guys, you may ask why we are doing this common or intersection domain. Well, that's because we'll see later, probably in a couple of minutes, that it's actually a theorem which says that like a domain of, if you have F and G, then the domain of F plus G would be the common domain, or domain of F minus G, or domain of F minus G, or F times G, right? The common domain would be the domain of the F plus G, or F minus G, or F times G, right? And for F over G, it's gonna be also the common domain, but then you need to exclude the values where G of X is 0. But anyway, we're gonna see this in a couple of minutes. But first, let's do this exercise, right? Don't forget, guys, when you want to find domain, square root, then you have to solve the expression under the square root larger or equal to 0. If you have division, you have to solve the bottom equal to 0. I mean, it's not like there are too many possible answers. So let me just write it down for you here. So it's let me recall. Okay, so division. If you have a division, so this is how you find domain, right? So if you have a division, you have to solve the bottom equal to 0, right? And if you have a square root, then you have to solve the expression under only the expression under the square root larger or equal to 0. So the expression under only the one which is under the square root, all right? Under the square root larger or equal to 0. Okay, so it's just there are two possible answers. Division, you solve bottom 0. Square root, you solve larger or equal to 0.
So if there's a square root, it's going to be larger or equal?
Yes, if there's a square root, it's larger or equal because you care about the sign, because you need your expression cannot be negative. So you care about the sign. So it's larger or equal means like it's positive or 0. Yes. And if it's division, it's just solve the bottom equal to 0.
Okay.
Sure. So Glenn, you're saying df. Yes. Yep. Correct. I'm here, guys. I mean, if you have any question, any remark, any problem, just let me know.
Sir,
Mm-hmm.
yeah, for the f of x, I go and minus 2, not 2.
Minus, you mean the final answer or for
No, no, no. The domain.
of f, just f?
Yeah, just f.
And you said you got -2.
Yeah, you
Negative.
see, I think Glenn had minus infinity and 2, but I had a minus 2.
No, it should be actually um, should be negative infinity, positive 2.
Okay, okay.
Not -2 because probably you forgot to. There's a sign missing, I guess. So Glenn, you're saying for domain of G, it's -4. Yes, it's -4 positive infinity, correct. I mean, you can even check your answer. I mean, for example, if you say the domain of f is negative infinity, -2. For example, if you don't include 0, right? I mean, because 0 is larger than -2. But if you plug in 0, there'll be 2 minus 0, and 2 minus 0 is still positive, right? So which means that you need to include. Uh, I mean, uh, negative infinity, -2. It's not the correct answer. You can always check or verify your answer. So, any guess what will be the final answer for number 1?
-4, 2.
Yes, absolutely, very good. Exactly, yes. It's going to be -4, positive 2. Yes. Yes, Glenn. So I guess number 2 is a little bit different, right? Because the f is a fraction, so it's kind of different. But I mean, it's always the same steps. So guys, I guess I will post the homework number 4 on, so I guess on Thursday, Thursday morning. All right. So we're gonna meet tomorrow. Homework number 3 is due tomorrow, and then I'll post homework number 4 on Thursday morning, as usual. With of course, with the lecture notes and the video, the lecture video. All right.
Sir,
Still working. Yes.
the intersection, are you supposed to put down the points, or you're supposed to put down only -4 and 2?
Yes. I mean, it's the whole interval. It's I mean, anything between -4 and +2.
So you put down -3, -2.
No, because the thing is, between -4 and +2, there is more than just the whole numbers. I mean, you can have also fraction, you can have decimals.
Oh, okay.
So when you say in interval -4, 2, it means it includes like 1/2 or -1.356. So it's not just whole numbers. I mean, you have also decimals, fractions, etc. Yeah.
Oh, okay.
Mhm. So any guess for number 2? Did anyone finish number 2? So Samira, you're saying -1, -2, 1. No, actually, I don't think it's. I think you're missing another interval. So it should actually the answer should be -2, 1, and then union with 1 positive infinity, right? Because all you have to do is to exclude the 1. And actually, oh yeah, and then you have also to exclude -1. So yeah, actually you're gonna have like the answer for number 2 would be like the union of three different intervals. It's not just one interval actually. Don't forget, guys. I mean, when you solve for the x squared minus 1 equal to 0, don't forget you have a square. So you apply a square root. So when you apply a square root, there is a plus or minus. So, I mean, what I'm saying is the solutions for, yes. Okay, perfect, Samira. Okay, perfect. So we have also to exclude -1, right? So if you get -1 and +1, right? So you have to exclude both, right? Negative and +1. Anyone else? Any guess for number 2? Now, so the tomorrow's schedule is like the usual. Yeah, it's just the usual schedule. Yes, Angel, Lenin, I guess. Right. Yes, it's just the usual schedule tomorrow. We're gonna be back to normal tomorrow. Yes. Yeah, back to the normal schedule tomorrow. Yes. Okay, so let me do at least the first First problem. Okay, number 1. So, so step 1. Here's my step 2. And here's my step 3, right? All right, so step 1, guys, function f. We start with the function f in the step 1. So function f, we have 1 plus square root of 2 minus x. So that will be 1 here plus square root of 2 minus x. As I said, so first question is there a division? There's no division, right? So that's a good news. Now, is there a square root? Yes, we do have a square root, and the expression under the square root must be larger or equal to 0. And the expression under the square root is just 2 minus x. So that's why we don't really care about the plus 1, right? Because only the 2 minus x is under the square root, right? So we have to solve this 2 minus x larger or equal to 0. All right. Again, the 1, it's not the end of the square root, so we don't really care about the plus 1, right? So it's just 2 minus x. You know, you solve for x, you subtract 2, then you're going to have negative x larger or equal to negative 2. And then you have to, divide by negative 1 to get rid of the minus. So once you divide by negative 1, then you're going to have x. But now, because we divide by a negative number, so we change the direction of our inequality, so it becomes less or equal to negative 2 over negative 1. That's positive 2, right? So my x, so here my x is less or equal to positive 2, right? So the domain of f would be negative infinity. It's less than positive 2, so it's on the left side of positive 2. So it's negative 2 to positive 2, and positive 2 is included because x can be equal to positive 2. All right? Any question, guys, about this? It's kind of similar to the previous example, right? So but still, I mean, is there any question about how I got this negative infinity positive 2? All right. Then for the step number 2.
The whole time, we don't have to worry about the number that's in front of the.
Yeah, this plus 1 here, this is, I mean, again, it's just because it's not the under the square root. We only care about the expression under the square root. That's the thing, right? Mm-hmm. So for g is g, where's g? G is a square root of x plus 4. So let me write down for you g here. So g of x is square root of x plus 4, and under the square root I have this x plus 4. Here's my x plus 4 here, so it should be positive or 0. So my x plus 4 should be larger or equal to 0. You subtract 4, then x is larger or equal to negative 4. And if it's larger, it's so we are done, right? It's x larger or equal to negative 4. And if it's larger, it means it's on the right side of negative 4. So then it's any number larger than negative 4. So then the domain of g would be negative 4, included, of course, positive infinity. It's on the right side of negative 4. So that's why we have to go all the way to positive infinity. And actually, no, Samira, I think your answer is wrong for number 2. We'll see it in a couple of minutes, right? So for step 3 here, guys, so we need to find now the common domain. Right, so the domain of f is this negative infinity positive 2, and domain of g is negative 4 positive infinity. So let me draw for you the number line. So here's my number line. I'm gonna need negative 4. Of course, here's negative infinity, here's positive infinity. I'm gonna need positive 2. So let me first start with the domain of f. It's negative infinity, positive 2. Positive 2 included. And then, so that's the domain of f. Now domain of g, it's -4, and then to positive infinity. So that's the domain of G. And then you can see the intersection between the red and the green intervals. So it would be this whole interval. So any number between -4 and +2. So, and again, guys, you need to keep in mind between -4 and +2, it's not just whole numbers. You'll have also decimals, you have fractions, you have infinity of numbers between -4 and +2, right? You have the decimals, so that's like infinity of numbers. It's not just whole numbers. So the answer, would be, so the answer is, so the domain of F intersected with the domain of G, so it will be -4 included, of course, and +2 included, right? So that's it.
Professor, let's say you didn't do the number line to find the domain. Can you just say that it's always the actual number that's from the domain of F and the actual number that's from the domain of G?
Yeah, yes, but I mean, yes. Yeah, but I prefer to to draw the number line because it's more clear, right? But yes, you need to take like this the smallest number, which is -4, and largest number would be +2. Yeah, so yes, but I think it's a really good idea to just do it on the number line. All right.
Okay.
Mm-hmm. Because sometimes, I mean, yeah, well, anyway, yes. Okay, so that's a fine answer. For number 2, so as I said, number 2 is kind of different. So let's see what happens with the number 2. So number 2, we have, so step 1, and here's step 2. And okay, so let's start with step 1. So my f of x is 1 over x squared minus 1. All right, so this is just, we have a division. All right, so if we have a division, then we have to solve the bottom. Here's your bottom here, denominator. So we have to solve the bottom equal to 0. Right, so we solve the x squared minus 1 equal to 0. All right, so it's +1 both sides. Right, so then x squared is equal to +1. Now we need to get rid of the square, so we're gonna apply the square root. So we're gonna apply a square root to both sides. So here's my square root, here's my square root. But then because this power is even, then we're gonna need the plus or minus. Right? Because it's the square, it's a even power. So we're gonna need the plus or minus, which means that x, so probably gonna erase this. This was a bad idea, I guess. So then x is plus or -1. So what I'm saying is, if my x is positive or -1, then the denominator is going to be 0, right? I mean, if you have x is 1, 1 squared minus 1 would be 0. So the denominator is going to be 0. Or if x is -1, it's going to be the same thing. It's going to be 0, right? In the bottom. So we have to exclude negative and positive 1 from the domain of f. So it's like, it's any number, real number, except the positive and -1. So the domain of f would be like from -infinity to -1, -1 excluded, and then union -1, +1, union with +1, positive infinity. And of course, +1 is also excluded, right? So you need to keep in mind, guys, again here, I mean, this interval -1, +1, it's not just 0. I mean, between -1 and +1, you can have like -0.5 or -0.25 or -0.333, etc., right? I mean, between -1 and +1, it's not just 0. It's like, infinity of numbers actually between -1 and +1. So that's why we need to write, the three, we have these 3 different intervals, right? So that's why this answer is the union of these 3 intervals. Is there any question about this this f? I mean, this domain of f? All right. Okay, so then So that's for step 1. Step 2. So I think you got this correct, Samira. So this is for domain of f, it's correct. Now for domain of 2, I think your answer is also correct. So step 2, sorry, so step 2. Step 2, so let me, so g of x, which was g of x, where's g of x? Yes, so it's the square root of 2 plus x. So square root of 2 plus x, square root of 2 plus x. So again, it's just, so this thing here and the square root, larger or equal to 0. So 2 plus x larger or equal to 0. That's easy to solve. So then x is larger than -2. So you're correct, Samira. So this domain of G would be -2 included, of course. Any number larger or equal to -2, so -2 included, positive infinity. All right, so now step 3. So we need to be careful here, guys. So this is domain of f. Let me write it down for you again. Domain of f is -infinity, -1, union -1, +1, union +1, positive infinity. All right, so this is the domain of f. Now, domain of G, so it's -2, positive infinity, okay. So you see, like here, Leah, in this case, I mean, unless you are very good with this intersection, then actually you need really to use this number line. So I'm gonna use the number line. I have, I have this -1, I have +1, and I need the -2. So I'm gonna put these numbers on the number line. So here's my -2, here's my -1, and here's my +1, here's my -infinity, and here's my positive infinity. So let's start with domain of f. So domain of f is any number except -1 and +1. So I'm going to use parentheses to exclude the -1, +1. Right? So it's any number except -1 and +1. So that's the domain of f. Now the domain of G would be from -2, -2 included. So I'm going to include -2 here. And then any number larger than -2. So the whole right side of the -2 is in the domain of G. Right? So that's the green interval. That would be the domain of G. All right. So now, what will be the intersection? So which interval is, at the same time red and green? Well, so you can see it's, everything on the right side of -2 would be common to the domain of f and domain of G, except, yeah, well, Kwame, yes, but except the -1 and the +1. Remember, -1 and +1 that are excluded from the domain of f. So if they are excluded from the domain of f, it means that they are not common to the f and g, right? Because it's not in the domain of f, right? So we have to exclude the -1 and +1 because they are not common. They are not in the domain of f. So the answer, so the green, the intersection would be this whole interval, except the -1 and +1. So that will be the intersection. So the answer, your answer should be, so domain of f intersected with domain of G. So we start at -2. -2 is included because -2 is common to both f and G. So it's red and green at the same time. So it's included. To -1, -1 is excluded, right? So you see, Samira, you have to exclude this -1 and +1 because they are not in the domain of f. So they are not common to f and g. So then union, of course, -1 to +1, and then union +1 to positive infinity. Right? And again, guys, -1, the interval -1 and +1, it's not just like a 0, like one number or 1 point. It's just infinity of numbers, right? Anyway, so that's the final answer. So we have the union. Remember, this capital U means the union, right? This is union, right? This is union here and union here. So we have the union of 3 different intervals. Is there any question, guys, about this example? Nope. Okay, perfect. So why we are doing this? Well, the answer is a theorem which says that. So it's a theorem which says that. So I'll probably we're gonna continue this tomorrow. But let me just write down for you the theorem just to see why this is important for us. So the theorem says the following: like if you take the domain of, so the domain of f plus g, or f minus g, or f times g is the common domain, is df intersected with dg, right? And if you have f over g, so the domain of f over g is the intersection with the values where g of x is 0 are excluded. Anyway, so we're gonna see in more details this theorem tomorrow, all right? And we're gonna have, of course, probably 1 or 2 examples, but I want to point out why this is this intersection domain is important. So anyway, so I'm gonna stop here, guys. Sorry, I went over time, I guess, but so we're gonna continue tomorrow with this theorem, all right? And yeah, and stay safe and take care, right? So I'm gonna stop here. Right?
Professor, did you do the attendance?
Yes, I did. Leah, I think I got your name. Let me see. No, I didn't actually. Thank you. Thank you for letting me. Yeah, thank you.
Okay.
I mean, if you have any question, of course, just ask me. Otherwise, I will see you tomorrow at the usual time at 12. Right? So see you tomorrow, and take care. Bye, everyone. Bye. Thank you, guys. Thank you, and see you tomorrow. Take care and stay safe.